and it has been a long years of experience of doing air pollution research. And if you don't mind, I do have some slides here that I can share with you. Oops, I think you have to approve my screen sharing, Antonio.
Oh, okay.
Yes, okay. Oops.
Yes, I think I can try
All
now.
right, thank you. All right. So I do. I want to thank Antonio and Start Green Generation for having me here to share my experiences today and share some of my knowledge in indoor air pollution. And I hope you'll be able to learn something and take home something, some knowledge about indoor air pollution and indoor air quality after this debate. Um, as I mentioned, I'm from the Philippines. I'm originally from Manila, from the University of the Philippines. I did my bachelor's and master's at the University of the Philippines, and then I flew in 2016 to Indiana to study at Indiana University and do environmental science. So while this is a more broad term, my research is still focused on chemistry and atmospheric chemistry. So basically, the chemistry of the air. um, and so, I came from the tropics, from a tropical country with all these beaches, and now I moved to the Midwest, which is all snow. Not all snow, but you have the four seasons of. Right now it's winter, so it's really cold. But both are equally beautiful, and I love both back home and here equally. But so, as an environmental chemist or environmental atmospheric chemist to be exact, I think about the environment in general and more specifically this region of the atmosphere, of the environment, which is the atmosphere and sometimes the biosphere, and how those interact with the anthroposphere, which is the humans. And so as an environmental atmospheric chemist, I think about two things, right? So I think about first, how much chemical species are we exposed to? So from the environment to us, how much of that we are exposed to. And then second is, how much do we as humans contribute to the environment? So what is given to us, and like what do we give back? And so those are the two things that I always ask in terms of environmental chemistry, and what I will share with you later in terms of more specifically indoor air pollution and indoor air chemistry. All right.
Yes. Thank you, Colin, for your introduction. Very glad to have you here. I think we can move on. I don't know, up to any questions, Maria, Mauro, Manu, and we'll move on. Uh,
Hello.
I think they don't have questions. I think we can move on.
Oh, okay. I'm so sorry
Yes.
about that. Okay. Yeah. So, um, well, first, also, I'd like to welcome Mauro Luis and Hermano and Miriam and Maria. Thank you so much for being here today to listen to this talk. And I hope later we can engage more on, it's not a one-way communication, right? While Antonio and I will share our thoughts on indoor air pollution, I hope, since this is a small group today, I hope we'll be able to exchange our thoughts on this too afterwards. So I'm going to continue sharing my PowerPoint presentation. So as I mentioned, these are the two things that I think about. So how much chemical species we are exposed to and how much do we contribute to the environment. And so now we kind of zoom into the indoors, where, you know, usually when we think of air pollution, we think, oh, the outdoors, because we see, pollution from like cars or from factories. When we see big plumes of smoke, we think, oh, air pollution from factories or air pollution from even natural sources like volcanoes, can emit these air pollution or air pollutants. But what we don't think about is that when we are indoors, we're also exposed to other pollutants and we're not insulated from pollution, not because we're indoors, we don't experience pollution. So definitely we are not insulated from pollution indoors. And so, as an extension of my diagram a while ago, here we kind of zoom into the atmosphere and we see here there's different layers of the atmosphere. But what we're going to focus in now is the troposphere and actually this area right here where you were close or where you are or where we all are at right now is so the kind of the boundary where we are in. There's not really a term for where we at right now. And so one of the professors at University of Colorado Boulder, Dr. Yosti Gao, has coined the term esosphere to mean inside or inner, which is saying that this indoor environment or this indoor atmosphere we are at now can be called esosphere, or since it is kind of different from what we will experience outdoors. It's a very different environment, chemically and physically also. When you are indoors, it could be different when you are outdoors. And so we are going to focus on the esosphere right now, but also how the troposphere or the ambient atmosphere can affect the indoors and vice versa. So, a general theme of my presentation would be that outdoors affects indoors and indoors affects outdoors. And it's one of the main take home messages that I want you to take home with you today, that it's not that because we are inside the home, we're not affected by the pollution outdoors. That's not the case, right? It still is a there's still an exchange between the outdoors and the indoors. And so, especially now during the pandemic, we spend, so this 90% of our time, this was before the pandemic, but now we spend even more time indoors, right? We spend about 90% of our time indoors. And if you think about it, we're only starting to learn what indoor pollutants we are exposed to. We've always thought of like pollution from like cars and trucks and factories, and in the past there has been much action towards this, but it's only recently that we're starting to learn and think about what pollutants we are exposed in indoors, from human activities such as cooking and cleaning and even just existing inside the home. There's a lot of surfaces, a lot of gassing materials, and a lot of other sources and sinks inside the home that can emit indoor pollutants. And so some examples of that of those pollutants or indoor air pollutants are listed here below. So you have your particles, formaldehyde, household odors and gases, ozone, carbon dioxide. So some of which may be emitted indoors, or some of which may be from outdoors and then going indoors through ventilation systems and stuff like that. And so what we don't realize is that we could be exposed to more pollutants indoors than we are outdoors. And then some of the health effects, why are we concerned of these indoor air pollutants is that it can we oops, we can have either immediate health effects such as irritation and headaches, dizziness, fatigue, or there could also be long-term health effects for us like respiratory diseases and increased instances of heart diseases and cancer. And so this is why we are concerned with these indoor air pollutants. And with this talk, I will focus mostly on airborne particles, but we will also touch up on how some household odors and gases can induce the production of airborne particles inside the home. And so, what I will share with you today is how, um, okay, I have to hide this so you can see the whole presentation here. So, um, what I will share with you today is my research about different types of particulate matter that have been produced either by primary emissions or by secondary processes. So, what the difference between these two are, so primary emissions are directly emitted, you can see them as smoke or plumes. On the other hand, secondary aerosols or secondary particles are those that are, initially emitted as gases and then react in the gas phase to form particles. So for a minute, we're gonna kind of forget about secondary emissions and look at primary emissions. Um, First, so primary emissions are usually from combustion processes, so burning. Like for example, as I've mentioned, outdoors, we see these plumes from factories, from smokestacks, and sometimes from like burning of what do you call this? Like grilling or something like that. And then you can also see this from the combustion of from the vehicles, so from like cars and trucks and all that. And um, in the this type of pollution outdoors have been very much studied, and such that there's already these ambient air quality standards, at least in the US, for this type of pollution. So it's being controlled, it's being monitored, and if you don't follow the guidelines, you're subject to some action, or basically it's being controlled already. And so we're doing well in terms of the knowledge in terms of primary emissions outdoors. However, indoors, we also do like burning processes indoors, like we cook, we do burn wood for heating, we light up candles, and then sometimes there's like cigarette smoke inside the house, and all of these are burning processes or combustion processes that emit primary emissions indoors. And so one of my previous projects that talked about primary emissions indoors is this project that I did way back in 2013 or 2014 at the University of the Philippines. What we did here was we built a what we call a wind tunnel for which it's like a testing facility for cook stoves and different types of fuels, and then also we tried to grill our own chicken. So in the Philippines there are these stores that sell what we call lechon manok, or in English rotisserie chicken. So basically they grill chicken all day long, and then so these emit smoke and particulate matter, and so we were trying to quantify that, the emissions from these, not just the particulate matter, but we were also trying to determine each component, like say for example water soluble components, or like the chemical composition. So we were trying to calculate numbers such that say for example you want to estimate the amount of pollution in a certain area, like say for example here, this is a part of Metro Manila. We were trying to estimate the emissions, the overall emissions in Metro Manila due to these grilling stations, we would just have to multiply that emission factor, what we call an emission factor, to the number of um, grilled chicken stalls within Metro Manila, and we'll be able to have an estimate. So there's no need for us to go to each and every stall and or each and every household to measure the emissions. We just have to multiply that certain number by the number of households or number of grilling stalls, and so that simplifies the quantification, and also it's less cost for researchers and for policymakers in terms of estimating. And then we also tried, so as I mentioned, we did grilling chicken, but we also tested different cook stoves and fuels. Like, say for example, these ones at the bottom you see here. So this is like a cement cook stove. This one is sawdust. This is a local fuel wood, in a grill. And then this one is a kerosene stove. And so we wanted to quantify all the particulate matter emissions and chemical composition of the emissions from these cook stoves. And as we know, some low cost households will still have these kinds of fuel cook stoves inside their homes. And we wanted to quantify how much exposure or emissions one could have if they have these kinds of cookware. So that's one of the projects that I did. Another project that I did pertaining to particulate matter indoors is collecting indoor dust in what we call complex workplaces. By complex workplaces, we mean establishments nearby a landfill. So this was nearby a big landfill back in the Philippines. And we say complex because a lot of the emissions could either be from the landfill or it could be from activities stemming from, an establishment being nearby a landfill. And so, we got samples from a junk shop, a pawn shop, and an elementary school. So we had this sampler. We did some chemical analyses, and you will see here, this is a clean filter, and these two are filters that are exposed about 3 hours. So imagine if all of that, you would inhale all of that in just a matter of 3 hours. It's kind of stark. And then so we did chemical analyses and some modeling studies. And what I want to emphasize here is that while there were no burning activities while we were sampling, we still were able to measure these. And these were, either super enclosed or kind of enclosed areas in which there's air from outdoors going indoors, right? And so while there was no burning activities inside the home, we still saw particulate matter that we think could be from the outdoors coming in. And so we're not totally insulated, even if we are indoors, especially in locations like this that are more complex and nearby a landfill or nearby a pollution source. And so going back to the big picture of particulate matter, we've mentioned the primary emissions. Now I want to go into the secondary emissions, and currently this is what I've been looking at. So the past two studies that I mentioned to you were previous projects. So currently I'm looking at secondary emissions of particles. And so again, as a reminder, these secondary emissions come from like two or more gas phase reactants reacting together to form a solid particulate phase or particulate matter. And so if you imagine, like we don't see gases around. We kind of smell them sometimes, but we usually don't see gases. And then they react and then form something that you can see with your eye, and so it is kind of concerning, right? Like what you don't it's not true that what you don't see won't hurt you. Like it could be argued that it's the other way around, right? And so what we did to observe the secondary formation is that we looked at primary VOC emissions. VOC meaning volatile organic compounds. So basically emissions from cleaning products or whatever consumer products we use inside the home. And so, say for example, you wipe down your table with a cleaning product and you smell the fragrance coming from the cleaning product. So that's volatile organic compounds that you can smell. And so we looked at primary VOC emissions. We looked at indoor oxidants, which some of these, especially ozone, come from the outside. There could be indoor sources of ozone, meaning it could be produced inside the home, but that's not very common. Usually it comes from the outside and goes inside through the ventilation systems. And then there's also these radicals, free radicals like OH and nitrate that are not too common indoors, but there are sources indoors as well. And then these two will react to form radical intermediates and oxygenated VOCs, which are intermediates still in the gas phase, and then they nucleate or coagulate to form and grow into secondary aerosols. And so, why are we concerned with all of these, right? So, again, as I've mentioned a while ago, it could lead to either short term or long term health effects. So, short term could be like irritation, for the eyes. Sometimes you scratch your eyes and you don't know why. It could be due to the particles inside your home. Also, not only that, but it could also lead to increased mortality from respiratory diseases. And not just the product itself will cause these short term and long term effects, but even the primary VOC emissions and the indoor oxidants will can cause these acute respiratory and sensory irritations. And volatile organic compounds from chemical products are becoming a more important role in the urban chemical pollutant mix. And so, since we've already looked at particulate matter and smoke and everything from the outdoors, we kind of have gauged that this is what we should take action on. And now we're some other pollutants are becoming more important in the chemical mix. Like, say for example, the volatile organic compounds are becoming more important. Like, we use a lot of like cleaning products and all these products inside our home that emit volatile organic compounds. And so the main question that I asked as a researcher that studies secondary organic aerosols and secondary particulates are, how do everyday human activities change the chemistry indoors? And with activities like cleaning and cooking and just being inside the house, how do these activities affect the chemistry or the air inside the house? And so, to answer this question, these researchers, so 20 plus research groups from 13 different universities, have collaborated in a project called Home Chem, or House Observations of Microbial and Environmental Chemistry. This was in 2018. So it is the one of the biggest, or if not the biggest, collaboration of chemists and scientists to study indoor air pollution. And so what we did, we lived in kind of like a bubble house at the University of Texas at Austin. So this one is a manufactured home. It is a functional home, but no one really lives here. It's not allowed to live in this house. We used it for research. It's fully functional. It has a kitchen, and it has a living area. It has refrigerator, dishwasher, and the additional instruments that we needed to use for measuring the emissions inside the home. So we were able to measure not just particulate matter, we were also able to measure, gases and radicals and a lot of other emissions during the course of a day inside the house. And the best part of all is we were able to eat the food that we prepared during the simulated activities. And so, one of the experiments that we did inside the house is what we call a layered day, in which we lived like normal human beings inside the house. And so, there were three volunteers that occupied the house from 8 a.m. to 6 p.m., doing different activities such as cooking and cleaning and working inside the house. And so the main conclusions from this study is that VOCs, or the volatile organic compounds, tend to build up inside the house over time. Not just in the air, but also within the surfaces of the house. So like tables and walls and all the surfaces inside the house, they do tend to build up. Organic components tend to build up inside the house over time, and outdoor pollutants such as ozone get inside and can react with these VOCs and organic compounds that have built up inside the house. And the most important conclusion, I think, is that human activities, ventilation, lighting, time of day, all of those are important when considering indoor chemistry. Like, say, for example, there are chemical reactions that will occur when the sun is directly coming inside the house. So that during this time, the the peak sunlight time during at the living room is at 5 p.m. And so that's when the peak of some reactants or some components are highest, because that's when the sunlight is coming in inside the house. And some reactions don't care much about the sunlight, but there are a lot of reactions that care about the sunlight and happen at certain times of the day. And so, to investigate more on human activities, we decided to look more into cleaning. So a while ago I mentioned we did the whole um, activity of like cleaning, cooking, and everything. But this time we wanted to, zoom in and focus on specific activities. So now we redid some of the experiments more intently and with a different suite of, not compounds, different suite of instruments to measure the whole process and track the whole process of like from gas phase to intermediates to the formation of the particles. And so we did that here at Indiana University. We tried cleaning using a commercial terpene cleaner. So this cleaner is sold in stores. It has a citrus scent. And so the citrus scent, what causes it is the compound called D-limonene. And D-limonene is a type of a terpene. It's a type of chemical compound. And so this chemical compound has a high propensity or high, it can form particles. It has a high propensity of forming particles when it's released in the air. And so what we did was to, clean this room. We mopped and then we wiped the surfaces, and then we let like ventilation to bring in ozone from the outside. And what we saw was that this type of cleaner was able to produce particles in the air that is almost equal to what you would experience outside for a longer period of time. And so we cleaned the surfaces, and then we measured these compounds, so from the precursors to the intermediates until the products, which are the particles, and we were able to see the formation of the secondary organic aerosols from the very small until their growth, the bigger particles. And so we can say that there has been some kind of formation of an indoor smog, if you will, during that very quick 10 to 15 minutes of cleaning. And it produced particles that are almost equal to the amount of particles you can be exposed to outdoors in an hour. And so that will get us, thinking about what kinds of cleaning products should we use inside the home, and what kind of precautions can we do such that we won't be exposed to these kinds of indoor smog kind of